Now we are going to look into 10.32, which is quite an important 10-mark question. So it's a very easy one. Direct application of formulas, just small things that you have to take note of. Otherwise, direct application of formula. So let's get started. The air pressure of a randomly selected tire put on a certain model new car is normally distributed, given the mean as 31 and standard deviation as 0.2. Right? What is the probability that the pressure for a randomly selected tire is between 30.5 and 31.5? That is the first part, the A part. What is the probability that x, if x is going to be that randomly distributed variable, it is between 30.5 and 31.5. Now, as always, we start with the formula, right? You know that to convert this to the z scale, we're going to use the formula x minus nu by sigma, where x is 30.5 minus 31 by 0.2, which is minus 0.5 by 2 by 0.2, which is 5 by 2 basically, which is minus 2.5. Likewise, when x is equal to 31.5, the value of z is same formula, you apply it. This time you will get a plus 5 by 2, which is plus 2.5. Okay. Now, what is the probability that z lies between minus 2.5 and plus 2.5? Due to the property of symmetry, you know that this is the same as 2 times probability of z lying between 0 and 2.5, right? So basically I also have to draw my bell curve, right, to show you. I'm drawing this in the z scale. So if z is equal to 0 here, this is z is equal to minus 2.5 and z equal to plus 2.5. So this is the area under the curve that we have to find out. So because 0 to minus 2.5, the area is the same as 0 to plus 2.5. So that's why I've put 2 times of that. So the value would be given for you in your papers. So you can straight away write it as 2 into 0.4938. If you do the sum along with me, you will know that the answer is 0.9876. Right? This is the answer for the first part. Now let's look at the B part. Probability that the pressure is between 30 and 32. Likewise, substitute in the same formula. Right? Can we do it? I've just substituted it in the formula. When x is 30, the value of z is going to be minus 1 by 0.2. So which is going to be minus 5. So basically it's nothing but 10 by 2, right? If I want to remove this decimal point, I multiply by a 0 on top. So it becomes 10 by 2. And likewise, when x is equal to 32, z is equal to 32 minus 31 by 0.2. So you get the same 1 by 0.2, which is plus 5. Now, if I have to draw the bell curve, right, you see that z is equal to 0 and between minus 5 and plus 5, it occupies the whole area under the bell curve. Therefore, probability that your x is lying between 30 and 32 can also be written as probability that z lies between minus 5 and plus 5, which the value is approximately equal to 1, right? Because it is the whole area, right, under the curve. So basically you know that the total area under the normal curve is 1. So this is what you will get. Right? Now let's look at the second part. The second part of the sum says what This is what we found out. The second part says, what is the probability that the pressure exceeds 30.5? So probability that x is greater than 30.5. So you know that when x is equal to 30.5, I think in the first part we already found out, right? When x is equal to 30.5, the value of z is x minus nu by sigma, which is minus 0.5 by 0.2, which is 5 by 2, which is 2.5, but on the negative side. So this is nothing but z greater than minus 2.5. Now if I have to draw the bell curve where z is equal to 0 and this is minus 2.5, if z is going to be greater than minus 2.5, it includes this whole area, right? So which is nothing but, if you take this side, right, on the positive axis it is 0.5. Likewise, between 0 and minus 2.5, due to symmetry I can write it as probability of z being between 0 and plus 0.25, plus 2.5, I'm sorry, right, plus 0.5, which is this area. Let me put it in a different color. The whole area here, right, it is 0.5. So what is the area under the curve for 0 to 2.5? We know that the value is 0.4938. So which is 0.4938 plus 0.5, which is 0.9938. Right, that's the answer for the second part.